Hello everyone, I'm Lucas. So today I will be going through the 2023 November AAHL question, paper 1 question. So this is a what we call a blind approach. So therefore there will not be any answer key at this point. So right now it's like February the 19th. So the mark scheme hasn't been out yet. So and I know some student might want to know like some of the solution of the question. So therefore I'll just this will be my suggested answer to give the overview of what will be the general approach to the solution. So first of all, disclaimer, I might have something that might be wrong. So please bear with that. Okay, so let's look at the first question. So the first question is shared with SL. It's a function question regarding with composite function. So we have a function here, f and g, where k is a real constant. So therefore, the access g of f. So simply go to g, and then whenever you see the word x, replace fx inside. So I'm trying to speed run the whole thing to minimize our time here because these are the SL question. So in theory, it should be easy. So given that g of f of 2 is 10, so we're just submitting 10 inside. 2 inside. So we have 4 minus 12 plus 9 plus k squared is 10. So just to double check here, so there's like 8. Sorry, minus 8. 10 minus 8. So this will be like minus 8 plus 9. Like this. So just to double check my mental math here in case I screwed up. So 10. So k squared equals 9. K would be, so possible values, so plus or minus. Okay. So first question, I think easy. We don't need 5 minutes actually. So second one will be a probability. I think this is also share of SL. So just remember in the formal booklet, we got this PA plus PB minus PA and B. So just sub everything in. So that looks something like this. Okay, so this will simply be 0.8. So that's A already. So B would be finding PA and B. So you can just draw a Venn diagram out. So the inside will be 0.8, so therefore the outside is 0.2. And the question asks you what is not A and not B, so that's everything outside. So therefore, obviously, it will be 0.2. Okay, or if you want to write down some stuff, then just write 1 minus the thing inside. Okay, that's okay already. I think this one will also be the SL question. So AHL will be sharing with SL a lot nowadays. So make sure every SL question needs to be correct. So and that asks for is this. So I think this is just simultaneous. So we just put n equals 4. Then we have 16p minus 4n. And we have this equals to 4t. And might as well divide everything by 4. Sorry, this should be q. My bad. Okay, this should be q. Q. Okay, so this is our first equation. Second equation would be sum of 5. So 5 squared is 25 minus 5q. This equals to 65. Divide everything by 5 again, then got this. And 65 divided by 5, I think it's 13, right? Is it? Yeah, I think so. And then we just use elimination here. So 1 minus 2, okay, to get rid of the q in the middle. Or I think 2 minus 1 is better. So we have positive numbers. P equals to 3, okay? And then we plug it into one of the equations on top. So 4 times 3 minus q equals to 10. So 12 minus q equals to 10. So q would be 2, okay? So we have 2 answers here. It's 5 marks. So part A is done. Part B, find the value of U5. So just remember sum U5, you can write it like this. Okay, so the first 5 term add together minus the first 4 term add together. So it's basically 65 minus 40. Hence, this is like, what, 25, right? Okay, yeah, so 2 marks here. So here is again a SL question, I think. I think here everything are SL question, to be honest. So we have a triangle here. So find area of this. So we're using 1/2 AB sine C. So this is like 1/2 times root 6 times 10 sine the BAC, the included angle there. Okay, so I'll try my best to like do the essay question as fast as possible because this is not the main focus for today. So BAC. So now we need to use this info here. So whenever you're like in doubt that you don't know how to change cosine to sine or vice versa, I just draw a right angle triangle out. So question, let's say this is theta, okay? So let's say this theta and cosine BAC, and this is SOHCAHTOA, right? So 1/5 means this is 1, this is 5. And then we just Pythagoras it. So let's say this is h squared plus 1 squared equals to 5 squared. So it's 25 minus 1, so h would be simply just root 24. Okay, so now, and then we sine this. So this we know, this is root 24. So finally, we basically know everything already. So sine BAC over A would be root 24 out of 5. And then the whole thing comes down to simply this, and which is root, I think 144, right? 120 plus 24, yeah. So which is 12. Yeah, so that's done already, 6 marks. Okay, we have a binomial question here. So we have this, and they give you the first few terms here. So find the value of n and k. So first of all, use the binomial formula, which is in the formula booklet. Kx part of r, like this. So since they gave us the first term, so obviously you put r is 1 and choose 1. So one part of everything is still 1, so no need to care about that. So this is kx. Okay, and they told you, oh, this is 12x. N choose 1 by definition is n. So nkx equals to 12. X, so nk equals to 12. So this is our first equation here, sorry. Okay, first equation. Second equation, you probably use this. So n choose 2, and then kx squared. And this equals to 28k squared x squared. So n choose 2, use the binomial definition. I mean, yeah, the NCR definition, sorry. 28k squared x squared. So this is like n times n minus 1, right? And then it cancels with the thing at the bottom. So there's no more factorial in the bottom. Okay, so this question is also SL, I think, because I remember I've done this before. So so this question should be easy in the AHL syllabus. So this is, let's say, 56, right? And then we'll move to the left hand side. Sorry. And then just factorize it. I think this 8 and 7. So 7n and 8n. So we want a minus in the middle. So plus n minus here. So n minus 8 and then n plus 7 equals 0. And then obviously n is 8. Okay. N cannot be negative 7 because n is the power. Okay. N is a positive integer. And the value of k. So we use the thing here. So n times k equals 12. We know n is 8, so k equals to 12 over 8, or divided by 4. So it's like 3 out of 2. Okay, so these are the answer here. And they told you that k is a rational number, so therefore this would be okay already. Okay, proven by mathematical induction. So it's a divisibility question. So first, always look for a domain of n. So think of the first number when you look at the domain, and it's a positive integer. So we consider n equals 1. So we have 5 times 2, 1, minus 2 power of 3 times 1. So the first step should be easy. So it's like 25 minus 8. So obviously this is 17. And therefore this is true for n equals to 1. Okay. And then next step, always assume n equals to k is true. So really depends on how you learn it. Some of them may learn pk and pk plus 1, doesn't matter. And then for divisibility, we'll always make it equal to the thing that we want to divide by times a number. So this is the definition of divisibility. It's your divisor multiply a number, a constant integer. So we need to write down the definition of a. A would be positive integer, and n is also positive integer. Okay, so we need to, since we declare a new variable, remember to write this down. Okay, so and then after the assumption part, we'll just consider the k plus 1, sorry. Consider n equals to k plus 1. So just rewrite the assumption in terms of k plus 1. Okay, like this. And then remember one thing, for induction, we would need to always use our assumption somehow. So first of all, I would try to make this one in the form of the assumption. So the assumption is 5 part of 2k. This is 5 part 2k plus 1. So I need to think of a way to get rid of the 2k plus 1 first. Okay, so this is 2k times 2 minus 2, 3k plus 3. Okay, so I need to somehow use my assumption. So again, this is 2k, this is 2k plus 2. So I need to somehow get rid of the 2 in the bottom, this part. So therefore, I will just multiply this out using indices law. Same thing here. So 2, 3k times 2 power 3. Okay, so now we need to use our assumption. So by assumption, we have something that's interesting. So if we make our 5 to the power 2k as a subject, then we got 5 to the power of 2k equals to 17a plus 2 power 3k. So we sub this into our formula above. So we have 5 power 2 times 17a plus 2 power 3k, and then minus 2 to the power 3 times 2 to the power 3k. And then we just multiply this in, so it's something that looks like this. So 5 is 25 times 2 to the power 3k minus, so this is 8 times 2 to the power 3k. And here you should have some prediction that we already have the answer. So just look at them one by one. So 5, so this is 25 times 17a. Here, 25 minus 8 is 17, coincidentally. And then here, every single of them can factorize to 17. So basically, this is done already. Okay, so therefore, true for n equals to k plus 1. Okay, and then just write out the conclusion again. So like, since n equals to 1 is true whenever n equals to k is true, n equals to k plus 1 is also true for n is a positive integer, proven by mi. So here I'm just lazy and don't write the full name for mi, but it's fine. So this is a structure that all of us need to follow in order to get the full marks for the 7 marks here. Okay. So next one will be, I think, a complex number question. So it's given that z equals to 5 plus qi. Satisfy this equation here. So when you see it's a 5-mark question, it should be a straightforward one. So we just sub it in inside. So see what happens there. Okay, and then we'll expand this at the same time. So 25 plus 10 qi. Here, be careful. Qi times qi is minus q squared, because I squared is minus 1. Yeah. Negative p plus 25i. Okay. And then here, if you're stuck, just remember one thing. For if they're just asking like simple complex number question without any cosine or sine or e, they're just basically asking you, oh, please help me compare the coefficient. So just compare the real number with the real number in the right hand side, and then compare the imaginary number in the imaginary side. Okay, so just compare the thing that I think easier here. Hey, sorry, I forgot to expand this as well. So give me a second. Times. So I think I'll just expand this quickly. So 5i minus q. Yeah. Okay, sorry, forgot about this. So again, I'll just highlight this again. So this is the I part, and then we have the q part as well. I mean the real part. Okay, so I'll suggest you find the imaginary part first, because that is, I think, easier. It's just q, 5, and 25. So we got this. Okay, so I think q would simply be 2, right? And then we compare the real part. So 25 minus q squared minus q, this equals to minus p. So 25 minus 4 minus 2, this will be minus p. So I think if I've done this correctly, hopefully I have p would be, I think, what, minus 19, right? So sorry, I'm just like doing this as quick as possible. So hopefully I'm correct. So 5 marks. So for these question, we'll always just compare coefficient. So this is just a general concept. Okay, so I think we have a integration question and a L'Hopital's rule, right, at the end. Okay, so let's see. So part A, find this particular integral here. I think we need to do this integrated by part. 6 marks. So let's try to integrate this by part. So there are 2 ways to do it. My way would be just in u dv equals to uv minus in v du. So this is my way of doing integration by parts. So for me, I'll try to put in one of the variable inside into dx by integrating it. So let's say differentiate what gives you x, right? So let's say differentiate x squared over 2 gives you x dx, right? If I multiply this to the other side. So therefore, instead of writing x dx like this, I'll just write this as like this. So this is my way of integration because I think this is a little bit faster instead of writing du, dv, and then all of those stuff. So I'll just write here. So instead of writing x dx, I'll just write the thing on top. So dx squared over 2. Like this, okay? And then remember one thing is that any multiplier, so here, the 1 over 2 here, it's a multiplier, so we just move that outside of the integral. It's none of their business. So we have something like this. Okay, so we can move the d something over 2 over outside because that is just a multiplier. You don't need to integrate or differentiate that. So here we just use a formal booklet definition from the formal booklet. So like this, x squared minus integration of x squared differentiate ln x squared. Put one more bracket here, forgot. Okay, so we have something that looks like this, and then might as well we just clean up the right hand side. So in here, what do we mean by this is actually differentiate ln x squared with respect to x. So let's try this as well. So differentiate ln squared will be chain rule, put the power down, power minus 1, and then chain rule the inside. ln x differentiate it's 1 over x. Okay, and dx here. And then we'll just observe things that to be eliminated. So x squared and x is none. So the whole thing comes down to 1/2 of x squared ln x 2, like this, the first part. So multiply this in. Second part, recognize here is a 2. This is a multiplier, so it could be moved outside of the integral. At the same time, the 1/2 multiply in, so therefore they cancels out. So there's nothing there already. Integrate of x ln x dx. Okay, so we have something that looks like this, and we somehow reduce the dimension of the ln x already from a square to a power of 1. Now we need to do the integration again the second time. So again, this is like integration by part again. So again, put the x inside by integrating x. So we have ln x d x squared over 2. Okay, and then we use that thing up again. So here I'll just do one more step here to make my step a little bit more clean. So again, multiplier, move it to the front, move to the front here. So we got 1/2 here. And then what's left is simply just ln x and x squared inside. So and then we just apply the formal booklet definition and then swap their places. So I think in my opinion this way it's probably a little bit faster because you don't need to write down all of your labeling there. So this 1/2 of x squared ln x squared minus 1/2 times x squared ln x. And then here, so we'll do this like quickly because I don't want to write too much stuff. So here it's like this, and then differentiate ln x 1 over x dx. Okay, and then they cancels out. So therefore, it's just integrating x dx. So therefore, this is just x squared over 2. Okay, just the normal power rule, like this, and then plus a c because there's no more integration sign. So 1/2 x squared ln x squared minus x squared ln x over 2 minus x squared over 2 plus c. Okay, so that's part A, which is 6 marks. I think it's a little bit harsh. I think we should work more because it's by part twice and it's kind of annoying as well. Okay, so hence show that. So they're pretty good. They give you the answers here. So if you're able to get this answer, then I think their 6 mark on top will be like automatically correct. So basically, we want to show that the integration here, right? I think it's exactly the same. Yeah. So part B, we'll just directly copy the answer that we got. And then we just no need plus c, remember, definite integral, no need to plus c. And then 4, 1, we plug in 4, 1 inside. Okay, so let's plug in one by one. So put 4 into x squared 16 out of 2. And then ln 4 square minus 16 again over 2 ln 4 minus 16 out of 2. So a lot of 16s here. And then minus, put 1 inside. So one thing that you need to remember is ln1 will be 0, so all of the first 2 terms are gone. So the only thing that's left is minus 1 over 2 at the end, because 1 squared over 2, okay, with a minus sign as well. So therefore we got this, and then we'll also look at the answer itself. 8. Yeah, so I spot mistakes here, so I can see it's over 4. So and then I'll look at here, why is it over 2, right? So I think probably we have integrated something that's wrong. So yeah, I think I have a mistake here. So these 2 multiply should be over 4. So this should be 4, my bad. Okay, this should be 4 and this should be 4. Okay, nice. Because you know the answer, right? And you can see it's like over 4, so therefore it should be over 4 somehow. And here will be 8 ln 4 square minus 8 ln 4. So here it's minus 1/16 over 4 plus 1 over 16, which is the question requirement, 15 over 4. So if we're able to get the, often if we're able to get the final term, often the first 2 terms will be correct as well, okay, unless there is some silly mistakes. So, and then look at the answer. This is ln 2, okay, and it is ln 4. So you need to somehow make ln 4 into ln 2, then you just need to remember, oh, we have a trick like this, okay? So 8 and then ln 2 minus 15 over 4. So this, again, put this to the front. So we've got something that looks like this, 2, okay? And then according to indices law, 2 ln 2 all squared would be 8 times 2 squared, which is 4, and then ln 2. Same logic here. So 2 to the front, we got 16. ln 2 minus 15 over 4. And then do this carefully again, then I think will have their answer at the end. Hey, sorry, forgot square. Okay. So I think this is exactly the question requirement, just to double check. 32, 16, and 15 over 4. Yeah, right? I'm just making sure I did not do anything wrong. Wait, let me see. Wait, this is a plus. Let me see the any mistakes here. See. Again, some silly mistakes here. Minus, somehow I get a plus. Minus, so therefore this should be plus. So therefore this should be plus. So 16, so 16 out of 4, minus 1/4, okay. So therefore, they have an answer to let you to check. So if you got wrong at the end, just look for the thing that used the wrong answer, and probably just look for a sign or the numbers there. Okay, so it's pretty good. They give you this. Okay, so I would say this question is pretty challenging for very chill as well. Okay. Okay. Question 9 is the last question, right? Yeah. Question 9a. Consider a function f of sine squared kx over x squared, where x doesn't equal 0. k is a real number, show that it's an even function. So again, we consider even function means left and right are symmetrical. So therefore, we just consider the reflection and see where are they the same. So we just plug this in. So we have sine square k and then negative x. And then our bottom would be negative x squared. Okay, so the top, sine squared simply means sine k. And if you remember, anything inside the sine it's negative. Since sine is a odd function, if it's negative in the inside, means it's the same as the negative as the outside. Okay, so the reason is because, let's say, sine, it looks something like this. Sine, it's what we call an odd function. So let's say if it looks something like this, so let's say f of x is sine, then f of negative x would be negative f of x, like this. Okay, so sine, that it's an odd function. So if it's inside it's negative, then it will be the same as the outside as well. So therefore we have this. So negative negative, so or negative square will be just positive anyway. So this x squared, and then put a square back, and this indeed equals to fx. So this is an even function here. So part B, given that fx equals to this and limits, given that the limit to 0, x to 0, equals to 16, and then solve for the value of k. So when you see the word limit, often for AAHL will be just the L'Hopital's rule. Okay, so first of all, we just already copy the question. So x tends to 0 of sine square kx over x squared equals to 16. So instead of writing fx, we just write that. And then for L'Hopital's rule, we need to test for some indeterminate form. So we put in 0 inside and see what happened. So sine, so this x is 0, right? So basically the inside 0. Sine 0 is 0. So this is 0. The bottom, 0 squared, obvious 0. So it's 0 over 0. This is an indeterminate form, hence L'Hopital's rule can be used. So we just differentiate the top and then differentiate the bottom separately. Remember, it's separately, not quotient rule, okay? So differentiate sine square will be 2 sine the thing here. And then chain rule, you need to differentiate sine, which is cosine. Chain rule again, differentiate the inside, which is just k, all over 2x equals to 16. So we got something that looks like this. And at the same time, just cancel this because it's none of their business. And then we just plug in 0 again, see what happens here. So plug in 0, this is 0. Sine 0 is 0. So 0 on top. And x is 0, so 0 in the bottom. Again, this is 0 over 0. L'Hopital's rule could be used again. So therefore, we just write this as limit as x tends to 0. Now we differentiate the top again. So the k here would be a multiplier. Just leave it at the front. So differentiate sine. So here it's a product rule this time. So differentiate sine will be cosine. Differentiate inside, it's k. Cosine kx. Remember, copy the second function for product rule. And then differentiate cosine would be negative sine. Differentiate inside will be k. Copy the first one. Yeah. And then all over 1. Okay. Differentiate x is 1. Okay, for information here. So I think that marks the end of this question. Almost there. Okay. So I can see all of them got k square. So I mean all of them got k. He just got this k, this is k, so I just factorize a k square out. And legit, let's try to put in x to be 0 inside. So cosine 0, it's 1. Okay. This is 1 as well. So this is 1, this is 1. So 1 times 1 is 1. And then the second part, we got 0. 0. Sine 0 will be 0 anyway. So this is like, I don't know, let's say this is minus 0. 16. Okay. So at the end, this will be just 16. So k would be, so let's see the restricted answer for k. So k would be a positive real number. So therefore k will be 4. Okay. So this is just a L'Hopital's rule question. But in my opinion, I think this is harder. More algebra involved. Okay. And this is the part for session A, and then I'll go through session B later. But common is, I think, for the AHL part, so which is number 6, 7, 8, and 9. I think this one is pretty. Sometimes this might be more challenging because often for divisibility we just have one thing that has a power, but this time we got 2 of them. Okay, but it's still the same workflow. Try to sub in the assumption inside. Actually, no matter which one you sub in, 5 to the power 2k or 2 to the power 3k, it'll be the same. So, and then this one, just make sure don't have any silly mistakes. Just compare real and imaginary part. This one's the more challenging one. I think majority, maybe like, I don't know, like maybe half of the student might not be able to do this one, because this is integration by part, but this is not a trivial one. Some of them might just use substitution here, but it will not work. This one, part A, I think some of them still might struggle part A. Maybe might forget that, oh, negatives, sine negative x equals to negative sine x. This is just something that you need to remember. Okay. And then the second part, just L'Hopital's rule. Just be careful of all the sine and cosine differentiation. Okay, and I'll go through part B later.